In this video, I'm going to show you how to solve the ALEKS problem called Deducing a Rate Law from the Change in Concentration over Time. To be perfectly honest with you, I have been putting this video off for well over a year because this problem is a beast. This is probably going to be the longest ALEKS video that I have ever made, hopefully the longest ALEKS video that I do ever make, and I am going to try to do this all in one take, so hopefully I don't say anything too stupid. Now, for this particular problem, we are being asked to determine and write the rate law for the reaction and determine the value of K, and the only way for us to do that is by creating a graph of the data that ALEKS has provided for us. Now, you know me, if there was a shortcut, I would be showing it to you. There isn't. You have to create a graph. ALEKS has you graph this data by hand, which I definitely don't recommend because we have graphing calculators, which are much faster. And I'm going to show you how to graph this data using Desmos. But you can use any graphing calculator that you want. So the way that this graphing is going to work, we are going to create 3 graphs. We are going to plot the time that ALEKS provided for us versus the concentration that ALEKS provided for us. We are also going to create a plot of time versus the natural log of the concentration that ALEKS provided for us. And we're going to create a third graph, time versus 1 over the concentrations that ALEKS provided to us. So again, we're going to make 3 lines: time versus HI, time versus the natural log of HI, and time versus 1 over HI. Of these 3 plots that we create, only one of them is going to give us a nice straight line. The other graphs are going to give us exponential lines. The graph that gives us the straight line will let us know if this is a 0, first, or second order reaction. If we get a straight line from time versus HI, then our reaction is 0th order. If we get a straight line from time versus the natural log of HI, then our reaction is first order. And if we get a straight line from time versus 1 over HI, our reaction is second order. What do we do with that information? We use that information to write the rate law. Okay, so let's jump into this. Now, like I said, there are multiple things or ways that you can graph this data. I'm going to be graphing the data using Desmos. I'm going to show you how to use Desmos to do this. It's a free website, and all you have to do, you don't have to actually log in. You can just go straight here and open the graphing calculator. And if you know how to use Desmos to graph, you can just kind of fast forward through this part. What we're going to do to enter in our data table in Desmos, we're going to hit this plus sign right here, and then we're going to hit this table icon, and then I'm going to begin by just copying the data, the original data that ALEKS provided. So I'm just going to do my time data first, and then I'm going to do the concentration data next. And you can see that I'm leaving off zeros that are unnecessary for the graphing purpose, just to save a little time. This problem's tedious enough as it is. And you can see that Desmos is already starting to plot those points for me. Now, what I need to do, I think ALEKS kind of tells you, ALEKS has you graph this by hand and then tells you to kind of eyeball it, which I don't think is a good idea at all. What I need to do next is draw a line, have Desmos draw a line through that data. And I'm going to do that by hitting this. Go back to this. Oh, that happened so fast. Hitting those 4 dots with a little line through them. We want to hit that right there. And then make sure down here that you have linear regression selected. And that is going to draw the line of best fit through my 5 data points. Now that actually looks really straight to me, but in fact it is not straight. Surprise, surprise, it's not straight. And the way that I know that that data is not straight is because I look down here, I'm going to kind of zoom in on this. I look down here at the R squared and R values. Those numbers are basically telling us how straight the line is, with 1 being perfectly straight. Now, maybe that's not the best way to say it. These R squared values, I'm not a mathematician. These R squared and R values are letting you know like how linear your data is. and R squared value of 1 means that your data is perfectly linear. Anything other than that means that your data is not perfectly linear. So even though that data looked really straight, because these R squared and R values are not 1, this is actually not a straight line. Looks really straight, but it's not. So since we don't have a straight line, that means that this is not a zeroth order reaction. And what we need to do now is plot the first order data and give that a whirl. Now the first order plot is going to be the natural log of our concentration. So what we're going to do is go back over here to this data table in Desmos. Let's see if I can get that again. And we can just click over that next column and we can add a second set of data. So I'm going to go down here and I'm going to type in Y subscript. Where's my subscript function? Maybe this works. Y sub, we'll call this Y sub 2, just to differentiate it from the Y sub 1. And here, I want the natural log of the concentration. So I want the natural log of 0.8, the natural log of 0.9, etc. And Desmos will actually do that math for you. So you can hit the equals sign, and then you can go over here and hit function and scroll down to, I think it's calculus. Where are we going to find it? I must have scrolled right past it. Hit that natural log button, and then just enter your concentration value. You can also do it. Perhaps this is where I'm not. There we go. You don't need an equal sign, just natural log and your number. And I'm not editing that out. You can also go over here just to the keyboard function and you can just type in the letters LN and it'll do it there. And so it's not showing us, it's not displaying the numerical value of the natural log of 0.409, but it is graphing the value of the natural log of 0.409, 0.209, whatever, and you can trust Desmos. It's legit. So I'm going to get all these natural log functions in here. Another thing that you could do if you felt unsure about this is that you could actually calculate those natural log values and you could just enter them in numerically. All right, so there's our Y2 data. That's all of our natural log data. And if this reaction is first order, then this data that we just created, those red dots, that will give us a straight line. So right now, it is still drawing a straight line through my Y1 data. I know that because that's what's selected here in this drop-down menu. So I'm just going to change this to do linear regression on Y2. And so now it's drawing a line through my Y2 data. And guys, look. There's that R squared equal to 1, R equal to -1. That means that this is a perfectly straight line. So that tells me that my first order, first order data is a perfectly straight line, and that means that this is a first order reaction. Now let's pretend like that had not given us a straight line, because some of you are not going to get a straight line with that. So if that were the case and you didn't have a straight line yet, what you would do is go back over here to your graphing calculator and you would just create a third column. And in your third column, we're going to call this one Y subscript 3. And what happened to my Y subscript 1? It's just going to be the same color, green. That's weird. Usually Desmos gives it a new color. And so your next set of data is going to be 1 over HI. That's what you want to graph in your next set. So we're just going to go 1 divided by our concentrations. 0.8 is our first one. So 1 divided by 0.8, and we're going to go 1 divided by 0.409. Oops, I messed that one up. 1 divided by 0.409. And 1 divided by 0.209, 1 divided by 0.107, 1 divided by 0.0546. That's our third set of data, and if you wanted to get to see if we can see with our eyeballs that that's not a straight line, but if you wanted to get to see if that was a straight line, you would come down here again to this linear regression spot. You would down here switch to Y equals 3, and now it is trying to draw a straight line through that third set of data, we can see here our R squared and our R values are not 1, which means that's not our data. Okay, that's not right. But for some of you, this will be the graph that gives you a straight line. Okay, not for me. I'm going to erase this information right here because I don't want to confuse myself. I'm going to erase this. We are looking at a first order reaction. Okay, so what do we do with that information? Let's see if I can scoot that over. Okay, once we know the order of the reaction, then we're going to write the rate law. The rate law is going to be the formula of the reactant. We're going to enter it in right here, HI, and we are going to raise it to the coefficient that corresponds to the order of the reaction. For me, it is to the 1, and then of course you can just leave that 1 off. If we had a 0th order reaction, our rate law would be KHI to the 0. If we had a second order reaction, it would be KHI to the 2. Okay, so I've got a first order, that's that. Then the next thing that we have to do is calculate the value of the rate constant. We don't actually have to calculate the value of the rate constant because we're going to be reading it off of the slope of the line. The way ALEKS shows you how to do the problem, it does have you calculate it by hand. For us, so I got to make sure that I'm getting on the right line here. So I'm still showing y equals 3 data, and I've got to switch this over to my y2 data. That was my straight line. That's the one that has the good R squared values right there. And this is what we want to do here is pay attention to the equation of the line. For a first order reaction, which is what we have, for a first order reaction and also for a 0th order reaction while we're at it, the value, the K, I got to word this in the right way, the value of the rate constant K is going to be the negative slope of the line. For first and 0th order reactions, you're going to have a line with a negative slope, and the value, the absolute value of the slope is going to be the value of the rate constant. For a second order reaction, the value of K is just the slope. In general, the value of K is a positive number. You know, your slope is sometimes going to be negative, sometimes going to be positive. So I'm looking at the equation of the line that I have here, y equals mx plus b format, and I can see that my slope is 0.0671044. ALEKS wants this to 2 significant digits, so that's going to be 0.067. And then it says, also be sure that your answer has the correct unit symbol. Ugh. Okay, so for units, the units of the rate constant differ from first order to second order to third order, etc., or 0th order. I'm starting to lose it. For a second order reaction, the units of the rate constant are liters over, ooh, that's going to be a funny way to write it, 1 over molarity times second. Or you could write it molarity to the -1, second to the -1. So these are just kind of tricky units. I'm going to erase the 0th right here. For a first order reaction, our units are 1 over second, just 1 over second, or you could write it as second to the -1. For a 0th order reaction, the units of the rate constant are going to be molarity over second, or molarity second to the -1, however you want to enter it. And then also let's make a note, K is the negative slope for a 0 order. Man, I've already forgot, what am I looking at? I have a first order reaction, so that means my units of my rate constant are second to the -1. Hey, I don't think that I said anything that was that embarrassing in this video. Good luck on this problem. Like I said, it is just a really cumbersome and tedious problem, but you know, Desmos makes this problem more manageable. Good luck.